Alright, welcome you guys. We're talking about density curves today. And density curves, just in their very basic, are just curves. They're always above the x-axis, like this. This is going to be a little bit rough. Let's go a different color. There we go. We're going to start out here. Something looks like this. And voila. Okay, now the area under a density curve is usually always going to be equal to 1. It's just going to be something set up like this. For example, here, let me bring you over this great paper from Purdue. Has a really good one. Okay. Now, idea of density curves, it's just given an overall pattern. Like if I had 5 bins of information, it would look like this. 10 bins would look like this. 25 bins, 50 bins, 100 bins, and then just density. Okay, it's always on or above the horizontal axis, has an area equal to 1, exactly 1 underneath it. And a density curve is an idealized description of a distribution of data. The mean of the density curve is denoted as mu, and the standard deviation is denoted as sigma. Now, when we actually do observations, a sample, we distinguish the mean of the distribution as x bar, and the standard deviation is s. Well, this is still mean, okay, and this is still standard deviation, just you have an idea between the two. Okay, a density curve has the following properties. The area under the curve and above any range of values is the proportion of all the observations that fall in within that range. So if you wanted to find the percentage of people that view something between, or have something between 140 and 80, it would be this amount in here, so that amount of people. Okay, the mode is the peak point of the curve. The median of the dense curve is the equals area point. The mean of the density curve is the bounce point, and the median and mean are always equal on a symmetrical density curve. So in other words, if you get really lucky, your mean, median, and mode should all be the same right there. Okay, so that's just a density curve, and what we're going to be doing is looking at all the information underneath it. Okay, so we're just going to be looking at it as a percentage. So when you look at, like, for example, let's say it roughly encompassed a 25 bins type of histogram. When you're looking at this, you're looking at it as a total percentage, so it's proportional. So in other words, I'm looking at this amount, so let's say however frequent this happens divided by the total, and that's the percentage I'm looking at in that range. Okay? Alright, but that's it for density curves, just something really simple. We'll be looking at it more when we talk about normal distributions next. Thank you. Bye.